Now we're going to start learning about the normal distribution, and we're going to specifically start talking about the standard normal distribution. So a continuous random variable has a normal distribution. So if it's bell-shaped and symmetric. So it has to start low, go up to its highest point in the middle, and then come back down in the same way. So the y values, the probability at any point, is given by this formula. And that's a pretty complicated formula. So E is a constant, as well as pi. X in there is what you'd be plugging in along the x-axis. And then there are two other things that you'll see in there. Mu and the standard deviation. So mu, the mean, is needed for a normal distribution. Where is the middle? And then sigma, the standard deviation, is needed. So for what we call the standard normal distribution, so what we'll be learning about first, the mean is 0 and the standard deviation is 1. Okay, so we're going to set up an example here on the next page. So we can actually use our calculator to find the probability between two values of a normal distribution. And that will be very helpful because otherwise you'd have to use either tables that have been generated, or to do it completely by hand, you would need what's called integral calculus and then this formula. So to use our calculator to find probability between two values of a normal distribution, we're going to use, we're going to go to this distribution, which is above the var. So we're going to hit second distribution, and we're going to look for the one that says normal CDF. So that's the second one right here. And so to calculate the probability between A and B, you'll do normal CDF from A to B. So if you're going between, say, 1 and 3, you would say normal CDF 1 to 3. If you want a probability of x less than A, well, technically we'd want from negative infinity all the way up to A. But since we can't put negative infinity in our calculator, we use a big enough small number, a number that's sufficiently negative. So we go normal CDF negative 1,000 up to A. And similarly, if we want a probability of x greater than A, so we'd want to go from x all the way up to infinity, but in the calculator we'll do normal CDF of A up to 1,000. So here's the setup for the problem we're going to go through. So it says, given a set of brand new clocks, consider how fast or slow they're running after 24 hours. So some clocks are going to run just a tiny bit fast, and some are going to run a tiny bit slow. So here's our assumptions. The amount of time that the clocks are off is normal, is a bell-shaped distribution. The average that it's off is 0 seconds. On average, they're right on time. And that the standard deviation is 1 second. So if the clock is running fast, we're going to call that positive. And if the clock is running slow, we're going to call that negative. So if we randomly choose one of the clocks, what is the probability that it will be more than 1.5 seconds slow after 24 hours? So more than 1.5 seconds slow means negative 1.5, and it gets more slow as it goes to the left. So technically we'd be going from negative infinity up to negative 1.5, but remember we use negative 1,000 up to, we're doing negative 1.5. So in our calculator, we're going to do second distribution, normal CDF. So our lower here is going to be negative 1,000. Our upper is going to be negative 1.5. Remember, our mean is 0 and our standard deviation is 1. If this menu does not come up for you and it just says normal CDF parenthesis, you'll put negative 1,000 comma. The comma is right here above the 7, negative 1.5, close the parentheses, and then hit enter. What did I put in wrong? Oops, I must have used a negative sign. Or, sorry, a subtraction sign instead of a negative. Negative 1,000 to negative 1.5. So here we get 0.0668. So that's our probability that a clock would be running more than 1.5 seconds slow. So next it says, what's the probability that it will be running more than 1.83 seconds fast? So 1.83 fast would be up here, and more than that would be going to the right. So we're looking for P that X is greater than 1.83. Again, technically this goes all the way off to infinity, but 1,000 is close enough for our calculator. So we're going to do normal CDF 1.83, 1,000. Our mean is still 0. Our standard deviation is still 1. So our lower in this case will be 1.83. That's always going to be the smaller number. Our upper is 1,000. Our mean and standard deviation are staying the same. And so our probability here is 0.0336. So the probability that a random chosen clock will be running more than 1.83 seconds fast is 0.0336. We're going to look at one more example. So it says, what's the probability that a clock will be running between 0.5 seconds and 1.4 seconds fast? So 0.5 would be here, and 1.4. Now this is one where you're not going all the way to the left or the right, so we won't need an infinity there. We're looking for X to be between 0.5 and 1.4. So on our calculator, we're going to do normal CDF. 0.5 will be our lower, and 1.4 will be our upper. So if we round to 4 decimal places, it's 0.2278. So that's our probability that a randomly chosen clock will be running between 0.5 seconds and 1.83 seconds fast after 24 hours. So that's how you calculate things with the standard normal distribution.